All right, for distances, we're going to look at this sort of situation. We've got a particle, and it's moving around in a straight line, and the speed of the particle is measured every 5 seconds. And so we know, like at when time is 0, the particle speed is 0. When at 5 seconds, the speed is 7. And at 10 seconds, the speed is 8 feet per second. So the thing's speeding up over time. What we'd like to do is figure out what is the distance that it has traveled during this time from t equals 0 to t equals 30. Now, we can't find that exactly given this information, but we can estimate it. What we can do for our estimate is we can divide this up into different intervals. So we could say from t equals 0 to t equals 5, we could use either 0 or 7 for the speed, or we could use the average of those two, 3.5. But let's do this. Let's use the velocity at the start of each of these to be the velocity during that entire interval. So from 0 to 5, the speed is going to be 0. From t equals 5 to t equals 10, the speed is going to be 7. T equals 10 to 15, speed we'll use for that is 8. So now this is the speed, or the rate. And remember, distance equals rate times time. So each one of these intervals is 15 seconds long. So it's 5 seconds long. So the distance we get for this first one is going to be 0. For this one, if it's 5 seconds and 7 feet per second, that's going to be 35. This is going to be 40. And then for the rest of this chart, we've got to go from 15 to 20, so we're going to get 12, 15, and 21. Now this 21, that's for the time t equals 25 to t equals 30. So notice we wound up not using the 25 at the end. But let's see, during these other times, let's see, during this one he's going to go 60 feet. During this one he's going to go 75. During this one, 5 times 21 is 105. So what we've got here is the distances that are covered during those different intervals, or approximations to that. So let's add this up. Let's see, that's 170. Let's see, 7 and 6 is 13, so that's 230, 40, 50, 60, 70, 80, 90, 200, and 15. So if I did that arithmetic correctly, this is 215 feet. I didn't do that arithmetic correctly. That's 315 feet. Let's see. That's 315 feet. Okay. Now another thing we could do. Keep in mind, this is going to be an underestimate. Because this is assuming that he went 0 feet per second during this entire interval, and then right at t equals 5, he instantly jumped from going 0 to 7 feet per second. And that's not how things work. You can't just instantaneously change your speed from one value to another. So if you think about what this is, if we were to graph this, what we just did was from 0 to 5, we said the value was 0. From 0 to 5, we went with 0, and then jumped up to 7. Then at 10, we jumped from 7 to 8, then from 8 to 12, and so on. So really what we're doing is we're finding the areas of these rectangles using the left endpoints, because we're starting at the left endpoint here, the beginning. The actual function here would look more like this. Now we don't know exactly what it looks like, but we know that it's going to hit this point, this point, this point, and so on. So another thing we could do is we could use the velocities at the ends of these things. If we did that, we wind up with 5 times, instead of using 0 up through 21, we wind up using 7 up through 25. And I'm going to add this one up on my calculator instead of trying to do it in my head. Let's see, 21 plus 25 plus 15 plus 12 plus 8 plus 7. It's 88 times 5 gives me 440. feet. Now this one's an overestimate because we use the velocity at the end of the 5-second period to be the velocity for the entire time. So this is definitely going to be an overestimate. So the actual distance that this particle moved is going to be somewhere between these two values. And maybe about the best thing we could do on this example would be to average the two. 440 plus 315, 755 divided by 2, 377.5. Maybe that's a better average, or a better estimate of this. But there's not a whole lot else we can do on this particular example because we don't have all the information about how fast he was going. We only have it sampled at these discrete times. So let's see. Ways we could improve this would be to take the average. One thing we could do, we could take the average of the starting and ending velocities at each interval. And this other one here is sort of a what if. In this particular problem, we can't improve it using this, but if the velocity were given to us as a function instead of a table, we could use shorter intervals. Instead of using 5 seconds, maybe we could shrink it down and use 1 second or 1 millisecond if we had all that information. That would be analogous to using more rectangles in the area problem. But anyway, this is how you can use the data to estimate the distance covered. All right, that's it for this section.